This is going to be the beginning of our recordings about the math of production and cost. And in the first recording, we're going to set out some definitions so that we can be clear what we're talking about when we use the mathematical notation. First is the concept of the production function. The production function is the rule or function that tells you what output is as a function of, as it depends on the quantities of the inputs. We have two of them here, L and K. Everything measured in their natural physical units, not in value terms. So output is the number of tons of steel, the number of computers produced, or something like that. And L and K represent labor and capital. Later on, we'll see that L represents variable inputs and K capital or fixed inputs. So Q is output, L and K are the inputs, and this is a description of the technology of production. You choose the amounts of L and K and it tells you the output that you get. What's called an isoquant is the implicit function for a given quantity of output that shows you all the amounts of L and K you can use to get that particular quantity of output. And we can show over here, we know that in economics class, these outputs are different isoquants, different levels of output. So here's an output Q bar. Here's a higher level of output Q prime, and so on. And along each of these isoquants, you have all the quantities of capital and labor you can use to produce that level of output. Next, let's define the marginal product of labor. The marginal product of labor is the partial derivative of the production function with respect to L, the quantity of labor, and similarly for capital, the marginal product of capital is the partial derivative of the function f with respect to k. Now we want to define something called the marginal rate of technical substitution. In this case, it's the marginal rate of technical substitution of L for K, labor for capital, and that's usually defined this way, minus the differential of K divided by the differential of L, given that there is no change in output, that is dq is equal to 0. And we can find that in a fairly straightforward way by remembering our definition of the total differential and applying it to the production function. So we know that dq is equal to the partial derivative of f with respect to L dl plus the partial derivative of f, the production function, with respect to k dk. And we want to make sure that dq is equal to 0, so we'll set it equal to 0. Recalling that the partial derivative of f with respect to L is just the marginal product of labor. And similarly for capital, df dk is the marginal product of capital dk. And referring again to our definition of the marginal rate of technical substitution, we see that minus dk over dl is going to be equal to the marginal product of labor over the marginal product of capital. And so with these few lines, we've been able to define the important relationships in production and production functions. To review, we have the production function itself Holding output constant, the resulting implicit function shows you the amounts of labor and capital that produce any given level of output. The partial derivatives of the inputs are the so-called marginal products, and the marginal rate of technical substitution can be found to be related to the marginal products in this way, so that the numerical value of the slope of an isoquant is equal to the ratio of the marginal product of labor to the marginal product of capital.